characteristic of a function. So, up to this point, you guys have seen equations written as y is equal to, and then some equation with a variable x in it. And we'll use the exact same one we have over here. So you guys are used to seeing this, y being the values on the y-axis, and x being the values on the x-axis. We plug values in, maybe using the table, and we essentially get some form of a graph. For this course, we're going to be working with something called function notation. Okay? So f, this is supposed to be an f, it stands for the function, and x. They can put any letter in these brackets. Okay? The letter or the symbol in that bracket represents the variable in the equation. So what they're saying here is the function with the variable x is equal to some number. Okay? Now this might seem confusing. Now this is also an equation you guys hopefully are familiar with. You dealt with it last year. It's a quadratic equation. Okay? So, for instance, if we're in function notation, they ask us to solve something. We have f at, let's say, -2. If I put that in, what I'm doing is I'm replacing the x variable in the equation with the number -2. So, right away, we're going to have is equal to -2, and the function is the squared part, the rest of the equation. Okay? So we plug -2 in, and we find that f at -2 is equal to 4. Okay? That same idea, let's say I did it again for f at -1. We're using the exact same function we had before. We're going to plug -1 into the function. That's supposed to be 1. -1 into the function. The function is still squared. So f at -1 is equal to 1. So I want you guys to recognize what we've just done is found coordinates. When the x-coordinate is -2, okay, that's what that's telling us. The y value is 4. When the x-coordinate is -1, the y-coordinate is a value of 1. Okay? That's how we plug things into our function notation. Now in this lesson, they've represented function notation a couple different ways. So, what I'm going to show you is through a table. I already know what these numbers are going to be if I plug them in. So when x is this, so with this exact same function, when x is -3, y is going to be 9. I'm just going to tell you these numbers. I know them already. This will be 1. 0 will be 0, and we're going to go down a little. And the reason I'm going to do this is I want to show you the many different ways you can write function notation. 1, 2, and 3. We're going to extend this, and it's still going to be 1, 4, and 9, these values. Okay? So, if somebody gave you this table instead of the equation that we had above, and they had asked you to find f at 2, they're looking for the x value, x being 2. So we go down to 2 with our x. And what is the y coordinate there? 4. So what that means is f at 2 is equal to 4. So your value would be 4 in this equation. Okay? No thanks. If they asked you f at 3, we find the x value at 3. So I look on my x's. This is -3, -2, -1. Okay, here's my x at 3. So I found it. Whoa. What is the y value equal to when when x is 3?
It's going to give us the table anyway.
They may give you 2 in table form. So our answer is 9 in this question. I'm going to show you the different forms they'll give it to you in this one. So f at 3 is equal to 9. And that's what we've just discovered here. Okay? So this is one form. Another form they gave us was in an equation form where we'd have to solve it ourselves. They give it to us like this in a table. Another form they're going to give us, and if you guys look in your textbook quickly, is they're going to give you 2 ovals like this. This is called a mapping diagram. We really only use this for this lesson, okay? This is mapping. I'll give you titles for this. So this is... No, that's no good. Okay, let's just write it. This is a mapping diagram. What was the last one we just used? That's right. This is a table of values, they call it. Table of values. So we'll fit that in. Above that, what would this be considered? An equation or a function. Yeah, that's right. This would be called, usually it calls function notation, something like that, okay? So we'll call it function or equation. And there's many ways to represent this function, right? So this function, we wrote it in a table like this. In a mapping diagram, it's very, very similar to a table. But they're actually going to give you some arrows in. So let's get our x values in. So for instance, they have -3, -2, -1, 0, 1, 2, 3. And then they have some y values. Now, if you notice with my y values, what's going to happen here is I'm going to only have 1, 2, 3, 4. In my y values, I do not repeat the same numbers over. So I'm going to have 9, 4, 1, and 0. And instead of writing them like in a table where they're directly beside each other, we use arrows to represent this. Okay? So I know that when x is -3, what value will it be? Yeah. When x is -2, what value will it be?
4.
When x is -1?
1.
When it's 0?
0.
When I have 1? That's right. So if you notice, I'm going to have two arrows pointing to the same value. Okay? It's a little more confusing, a mapping diagram. For 2, what will we be pointing to?
4.
Yeah, it's starting to look like shoelaces. And 3 will point to 9. So, to directly look at this could be very confusing. We'll need to be able to get actual coordinates from this. So if I look at -3, well, I know -3 is 9. Okay? So we have -3 and 9. That's a coordinate. Scroll up just a little. If they give us -2, the y value would be, so we have -2 and 4. -1, it's just 1, okay? So always just try to make sense of it. What would these coordinates be, okay? And again, they can ask you the exact same things. If they asked us what f at 2 was, well, f at 2, we would follow the arrow. F at 2, whoops, takes us to 4, okay? If they'd ask us f at 3, well, f at 3 takes us to 9. And that's how I know my values. Okay? So I'd write all my coordinates, maybe to help. You don't have to write the coordinates every time, but this is a style that will help you guys. 1 is 1, 2 is 4, and 3 will be the value of 9. Now, finally, look at the entire page. So we've gone through a couple of different ways here. We've talked about the equation or the function notation. They can represent it as a table of values. They can represent it like a mapping diagram. And we're using the exact same equation every time. I haven't changed this equation. The other thing they could do is set it up in a graph form. And then you have to find the exact same answers using a graph form. So with a graph, I'll use the same equation. Okay, I'm just going to quickly put a graph up here. Okay. So let's say we have our graph. I'm going to graph this function. I already know what it looks like, so don't worry about how I got the numbers yet. We'll talk about that a little later in this course. These are some major points along the graph. Hopefully you guys remember this from last year a little. Anyone remember what this graph represents? Parabola or quadratic, right? Maybe they give us something like this. And if they give us this and they ask us find f at 0, I have to find the y coordinate at when x is 0. So when x is 0, what's my y coordinate?
0.
Yeah, it happens to be 0 in this case. What about if they asked us... What's that?
Can I get anything else than 0?
No, because that's the only value it hits there.
But like I'm saying, like if it was a different kind of like.
If it was a different graph, sure, it could have a very different answer, yeah. That means that's this function or this equation. So let's say we had f at -3. I go on my x values, 1, 2, 3, and I look for the y coordinate. What's the y coordinate at -3? 9. So f at 3 is equal to 9. We've just solved it. Okay?